Hey there everyone! In today's Future Programmer YouTube tutorial, I'll be showing you how to create a photomosaic generation program using Python that can turn a picture like this one into an artwork like this. Without further ado, let's get started. Right now, in my Python Photomosaic project folder, I have an empty Python file called main.py and a picture called image.jpg, which is a picture of a waterfall that I took a while back. I will be using this photo as the input image to my Python project, though you can certainly use whatever image you want to use for your own project. Now, do keep in mind that I have resized this picture to be 1500 pixels by 1000 pixels so that our Python program won't take up too much time when running. You can certainly use a larger or a smaller image depending on how long you're willing to wait for your Python program to run. In addition to this input image, we'll also need a set of tile photos. I'll explain to you why we need those in a second, but let's first go to a website which I have linked in the description of this video called kaggle.com. This is an animal image dataset. This consists of about 5,400 animal images. We don't care that it's in 90 different classes or about the context, since we only need the pictures. So after you create a free account, you can click on the download button right here. And I'm going to save the archive.zip file in my downloads folder right here. Now after the download is complete, I will click on the archive.zip file right here. You can see we have a folder and a text file. You want to double click on the folder, and then we have another folder called animals right here. I'll be copying the content of this folder into my Python Photomosaic folder right here. So you can either just drag this into my folder, or you can copy and paste it in here. Either would work. So now in my Python Photomosaic project folder, we have the tile photos, the input image, and an empty Python file. Now for both of these, you can choose to use your own images if you can find another dataset that you like, or maybe you have a photo collection of your own you would like to use. The more images you have, the better the end product will be. And keep in mind that we'll be using different colors, so the wider the range of colors in your photos, the better. And then here you can also use your own input image as well. For this Python program, you'll need two external packages that do not come with the Python standard library, so you'll need to install both with the command pip install opencv-python in your terminal. Now you can see opencv-python and numpy have been installed. If you see an error that says something like pip is not a recognized command, I will leave a video in the top right hand corner of your screen right here, which you can click on to solve that issue. Before we finally get started writing our Python code, let's first understand what we will be doing on a high level. How can we turn an image like this to an image like this? Now, if you zoom in to the image on the right, this output image, you'll actually see that each of these small squares are images on their own. These are our tile images. So what we will be doing in our program is we'll cut our input image, in my case, the waterfall image, into small squares, small grids. And then we'll take our tile images and put it in each of these small squares. So each square will be replaced by a tile image until the output will only be these tile images next to each other. We can't just put any tile image anywhere in our input though. That would not look anything like the original picture. So we have to match the color of each of these images to the colors of each of these small squares so that they match up enough that we can still see a resemblance of the original image in our final output. So that's the general idea of what we will be doing. Now we're ready to get started writing our Python program. So let's first import the modules that we'll need. We'll need the pathlib module, the JSON module, the OS module, the math module, as well as the random module. We'll also need the numpy and the opencv packages. Now opencv is imported as cv2 in Python, so keep that in mind. Now let's read the animals folder. We want to have a list storing all of the file names of the images. We want to have a way to finding all of these images. So the way we can do that is creating a pathlib.path object in Python. So let's create a variable images dir is equal to pathlib.path animals. So this will create a path object for this folder, this animals folder right here. If you are using another dataset for your tile photos, feel free to change this to whatever your folder name is. Now in this case, my file structure for this animal folder, we can see we have the animals folder, and then we have some subfolders, which are the names of our animals. And inside of each subfolder, we have around 60 or so images. So what we can do here is we can create a list called images. Now this is going to be a list of images.glob, and then we're going to pass in a string. So this method is going to match anything inside of the animals folder if it matches this pattern string right here. So we're going to put a wildcard. The star here, the asterisk, is known as a wildcard. So we're matching anything. In this case, this first star is going to match antelope, is going to match badger, is going to match bat. And then using double backslash, we're going to enter each of these subfolders and use star.jpg. So we're only looking for the JPEG images files, and let's print out images. In fact, let's just print out the first, let's say, couple of images. We can see our first Windows path in this list is going to be 02 something, which if I scroll up more, you'll see is the first image right here. And then the second one, 03D something, that's the second image right here. In total, we have a length, let's see, length of images is going to be 5400. So we have 5400 image file paths inside of this images list. Now we want to determine what the colors of each of these images are. And the reason why we need to do that is we can't just put any tile photo anywhere on this input image. For example, if we have an animal picture that is red, it probably wouldn't even go on this input image because there is no color red on this entire input image. So we need to first determine what is the average, what is the mean color of each of these images so we can better match these pictures onto our input image. And we can do that. Let's first create a function to do that. So let's create a function called, I put too many spaces. So let's create a function called getAverageColor. Now this is going to take an image as the input. And what it's going to do, I'm going to copy some code in. Since this is not really too important, we just need to know that this is going to give us the average color of an image. So we're going to use numpy and some array manipulations to get the average color of an image. Now we can use this function for all of the images in our animals folder. So let's create first a dictionary called data, an empty dictionary. And then for each image path inside of images, because this list is actually not a list of images, it's a list of images paths, file paths. And we're going to use cv2.imread to read the string version of the image path and then store that in a variable. Let's call this image for now. And the average color of this image is going to be returned by getAverageColor, and we're going to pass in image. Now, I'm going to do this a little bit differently than you may expect. Now, you probably would want to do something like this initially. You might have an idea of doing it. For example, we have a file that is called a.jpg, and you have, for example, the RGB representation of the average color of that specific image. So you may have something like this. Maybe this is a black image, so it's 0, 0, 0. And maybe we have a white image, maybe like b.jpg, and you have another maybe 255, 255, 255. I'm going to do this actually the opposite way, and you'll see why I'm doing this in a second, but I'm actually going to store this in such a way. So for example, 0, 0, 0, and then I'm going to put in a list of images. So for example, a.jpg and maybe d.jpg and maybe, I don't know, some other images as well. And then, for example, for another image or another color, we may have 255, 255, 255, and then we're going to have maybe b.jpg. Now, The reason why I'm doing this is actually because we're rounding everything up here. So numpy.around average color with a decimals of -1, this is going to round all of the RGB values that is returned from this function to the nearest 10. So if an image has 255, 255, 255, it's actually going to be rounded to the nearest 10th. So what we're actually going to do is we're going to put a bunch of images here. So when we're looking at this input image, let's say the top left hand corner, that right here, it's a green color. So it may be 0, 100, 0. Now it's probably not that, but let's just use that as an example. 0, 100, 0. And then we're going to look in our data dictionary, look for the one that has 0, 100, 0, and it's going to randomly choose one of the images in this corresponding list. And then it's going to put, for example, d.jpg on the top left-hand corner of our input image. So that's why I'm doing this in this way. So we have the data dictionary, and we have the average color of each of these images. And let's do this. So if the string version of the tuple average color is already in data, so if this is already a key of the data dictionary, we're gonna do data string tuple and then average color, and we're gonna do dot append string image path. Since we already created a key for string tuple, this specific average color, so we can just append it to that list. Now, otherwise, we want to do data string tuple average color, and I'm going to create a new list for that key, string image path, like this. So let's just store this inside of a file so we can take a look at what this looks like. So let's do this with open. Let's just call this catch.json, because we're going to catch all of the information of all of these images in a JSON file, so we don't have to go through all of this process every time we open our Python program. And we're going to write to this file, so W right here as file, that will be fine. JSON.dump data, and then file. Let's just use an indentation of 2 spaces. Sort keys is equal to true. And let's just print out for good measure, catching. Done. Now if I run this program, it may take a little bit of time while it looks through all of the images, the 5,400 images of our animals folder, and it's going to take a look at all the colors and store the color information in our catch.json file. All right, so on my left-hand side, you can see we have a catch.json file here, and I'm gonna just close this terminal. And in this JSON file, we can see we have an object, and then inside of it, we have the key. These are all strings. These are not tuples. These are all strings. So we have these strings corresponding to lists. And each list, it may store just one element. That's fine. Or it may store multiple elements. In which case, for example, these images right here, these all match this specific colors. They're all around this color. So in our image.jpg file, if we have somewhere on this image, a tile of it is around 10, 10, 10, we can just choose any of these images and paste it onto our image.jpg file. So now let's take a look at our actual input image. So image is equal to cv2.imread image.jpg. Now, for the next part, we need to find out the height and the width of this image, which we can do with image height, image width, and then let's just use an anonymous character here for image.shape. This is going to return the height, width, and channel information of this image. We don't need the channel information, so we can just discard it this way. And we need to determine what is the width and height of the tiles of our photomosaic. So how wide and how high are our tiles going to be? In this case, I'm going to have a height and a width of 10. So, well, actually for now, let's just keep it at maybe, let's say 50. So image height is going to be 50 and image width is also going to be 50. Now to calculate the number of tiles that we're going to have throughout the height and the number of tiles that we're going to have throughout the width, we can do this. So num tiles on the y direction, so the kind of the height throughout the height, and the num tiles width is going to be image height, integer division by tile height, and image width, integer division, tile width, like this. Now lastly, we want to crop the image a little bit. Now in this case, I have already cropped, I've already resized this image. Right now it's 1500 pixels by 1000 pixels. But if we have 1503 pixels by 1008 pixels, then the 3 pixel in the width and the, did I say 3 pixels on the, or 8 pixels on the height will be discarded since we don't need that in our actual final image. So we can just do image is equal to image tile height multiplied by num tile height, and then tile width multiplied by num tiles width. So this is basically cropping everything until this on the y-axis, and it will be cropped until this coordinate on the x-axis. So now we have the image. Let's just show this image really quick. So imshow, we're going to use cv2.imshow. Let's just call this image, and the image is just image. And let's use weight key of 0, so that will be fine. Running this, well, right now we have a problem actually. We're going to catch the file every single time we run our program. And I forgot to have an if statement up here. So we only want to run all of this code only if we don't already have a catch.json file in our project directory. So what we can do here is we can say if catch.json, this file is not in os.listdir. Only then will we run everything until the catching done part right here. Otherwise, we don't have to deal with the animals folder at all since we already have the catch.json file, so we can just look for images using this JSON file. So we go directly to reading the input image. And you can see, well, this looks the same thing as our old image because it's not actually cropped since it's already a perfect number resolution. So we don't need these two lines anymore. And let's now cut this image into tiles. The way we're going to do that is we're going to have we're going to have the coordinates, the 4 corners of each tile stored in a list. So tiles is going to be an empty list. And for each y, I'll explain this in a second. For each y in range, I'll be range 0 image height, tile height. And for each x in range 0 image width, tile width, we're going to say tiles.append a new tuple y plus tile height, x, and then x plus tile width. So what this is doing, we're iterating through our image. So we're going to have a y, which is going to start at 0, and it's going to go until image height, and it's going to have increments of tile height. So it's basically jumping the image height. It will start at 0, it will jump down 50 pixels, 50 pixels again, 50 pixels again, and while it's doing that, the x variable is jumping along the width, 0, and then it's going to be fixed 50, 50, 50, 50, 50, until it jumps to the end of our image. And the y and the x variables are both moving up, so we're going to end up on the lower right-hand corner of our image. And then the tiles.append, this line is going to add a new tuple to our tiles list. Now this new tuple is going to store the coordinates of each of our tiles. So it's going to be the y, this will be the upper limit, and then the lower boundary, the left boundary, and the right boundary. And we're going to use this in a second. So now we have a list storing all of the coordinates of the tiles of our image. Now we want to actually go through the image using that information. So for each tile in tiles, y0, y1, x0, x1, are going to be type. So this is, again, this corresponds to this right here. And let's just unpack all of these values in our tuple to y0, 1, y1, x0, and x1. And what we're going to do is we're going to have the average color of each of these tiles. So average color is equal to get average color image, and we're going to not find the average color of the entire input image. We want to find the average color of that specific tile. So we're going to have image y0 to y1 on the height and x0 to x1 on the width. Now this may sometimes raise an exception, which doesn't really matter, so we can just put it in a try except block. So try except exception, continue. We can just continue on without looking at that specific tile if there's an exception thrown. Now we want to find the closest color to that average color which exists in our animals folder. So we want to find the color that best matches that average color in our JSON file. So in our JSON file, let's say, for example, let's just take an example. If average color is 11, 11, 11, just for argument's sake, 11, 11, 11 right here. It'll be 10, 10, 10, but 11, 11, 11 is the closest to this color right here. So we want to find a way to determine what is the closest to this right here. Well, what we can do is we can use another function. So right up here, we'll have a new function which we'll call get closest color. So get closest color. And we're going to pass in two arguments which may look very similar, but they're actually different. So color and colors. The difference between them is the first color is actually going to be the color that we're trying to match. Now this will be the average color in this case, and colors is going to be the keys of our catch.json file. It's going to be a list containing all of these tuples. So what we're going to do here is I'm going to copy some code in again, and I'll explain what they're doing in a second. So let's just paste this in. Now we're going to find the RGB values of our color, of our average color. And we're going to use a for loop to go through all of these colors and find the closest one in distance. This is the distance formula in 3D to this color that we're looking for. And so we're going to have a difference. The minimum difference, we're going to set an infinity for now. And the closest color, we currently don't have one because we haven't entered the loop. Now, when we do enter the loop, we'll first evaluate the RGB color of each of these colors. So all of these colors, 0, 0, 10. Now, keep in mind that we have these as strings, and we can't find the RGB colors from a string unless we put it into a tuple. So what we can do is, if we have a color like this, what we can do is we can create a new color. Let's just call this x is equal to eval c. Now, this is going to take this string and essentially evaluate it. In this case, it will be evaluated to a tuple. So type of c is a string, but type of x now is a tuple. And we can actually separate it into RGB values. So RGB is equal to x. Now R is going to be 0, G is going to be 0, and B is going to be 10. So that's what we're doing here. So RGB is equal to eval C. And then we use the distance formula. Difference is equal to math.square root, the difference between R and CR squared, plus the difference between G and CG squared, plus the difference between these two squared, and we have the difference. Now, if the difference is less than the minimum difference that we have here, then we will reset the minimum difference to be the new difference and set the closest color to our color that we're going through, the C right here. And lastly, after we have gone through all of our colors, we're going to return closest color. And I just realized that the 11, 11, 11 example that I used earlier actually doesn't make any sense because our average color is going to be rounded to the nearest tenth. So a better example perhaps would be something like, maybe there is not a 000 in our catch.json, but let's say on our image there is a part which is 000. Perhaps this is dark enough to be 0, 0, 0, then we're going to find 0, 0, 10 as the closest color to that 0, 0, 0. So now we have the get closest color. So what we can do here is find the closest color. So closest color is equal to get closest color. And we're going to pass in average color and data.keys. And what we're going to do after we find the closest color is we're going to find an image. Hold on. So we're going to have, so our result, our closest color may be 10, 10, 10. But that's useless to us unless we can find one of these images to use. So we're going to use random.choice here. So image path, I'm going to just call this iPath, is equal to random.choice data string closest color. So we're going to convert the closest color, this tuple, into a string and pass that into data, our dictionary. And then we're going to say random.choice this right here. So it's going to randomly choose one of these images. Maybe it will choose this one right here. Maybe it will choose this one right here. We don't know. So it's going to randomly choose one of these. And that is the image path for the image, which we will paste on that specific tile of our image. And I just realized that we have a problem. And the problem right now is we don't have a data variable. If we already have a catch.json, we try to access data right now, we don't have a data because we don't run this, so we have no data variable. So what we can do instead is with open catch.json, we're going to read file. So data is equal to json.load file like this. So now we have the data variable. Cool. So let's go back to our image path. We have image path. We need to read the image. So cv2.imRead image path. Let's store this in a variable called I. But now let's take a look at our animals photo once again. This picture is, well, if you look at the resolution, it's even larger than our input image. We can't just put this into a small tile of our input image unless we resize it. And furthermore, each of these images are different sizes. So we have to resize all of these images to a specific size. In this case, the tile width and tile height size. So I is going to be equal to cv2.resize I, and we're going to have a height, or sorry, a width of tile width and tile height. And now we want to actually paste I onto our image. So image y0, sorry, y, that will be y0 to y1, and then on the x direction, x0 to x1, this will be equal to I. And let's just, for good measure, show our image every time we add a new tile picture onto it. So cv2.imShow image, and let's just display the image, and cv2.waitKey, this is going to wait for, I believe, one millisecond, I believe. So we can actually see the image change. And lastly, after all our hard work is done, what we can do is we can just use cv2.imWrite to write a new photo, new file called output.jpg with the data of the image variable that we have. So now let's take a look at if this worked. Let's run main.py. And you can see we have, well, right now it doesn't look very clear because we're using a, what's it called, a tile width and tile height of 50. So it doesn't look anything like the original image. Well, it looks somewhat like the original image. You can see that the center part is rather white/blue, and the, for example, the upper left-hand corner, that's rather green. And it does look somewhat similar to our input image. But in order to make it even better, we can change our tile height and tile width to something smaller, like 10 pixels. So every 10 by 10 square on our input image will be replaced by our tile images. So let's run this again. This might take a little bit of time. You can see that we do have images being added on throughout our picture. So now our program has finished running. Let's take a look at the output. So this is our input image, and this is our output image. It looks very similar to our input image, although, well, it is slightly different since it's not an actual image, it's a photo mosaic. We have a total of a 70, an 80 line program to turn an input image like this one to an output image like this one. And that's it for this photo mosaic generator program in Python. If you found this tutorial to be helpful, please consider subscribing down below so you won't miss any future updates. And with that said, thank you very much for watching this video, and I hope to see you in more programming tutorials.